So we'll have a quick session on recursive definitions for the subject discrete mathematics unit 1. And recursive definition has the word recursion, and we all computer science people know the meaning of recursion. So it's a process which repeats itself. In recursion, there is a function call which will be calling itself directly. So this recursive function has two parts. There will be a smallest argument definition, and the second part will be the nth term definition. So why we use recursion is sometimes it is difficult to define an object explicitly. So it may be easy to define this object in terms of itself. Usually recursion is used to define sequences, functions, sets, and your recursively defined functions has two steps. The first step is called as the basis step, where we'll be specifying the value of the function at 0. Then the second step is a recursive step. Okay, here we'll be giving a rule for finding its value at an integer from its value at smaller integers. This type of definition is called as a recursive definition. We can take an example here. Let us say f is a function which is defined recursively. F of 0 equal to 3 and f of n plus 1 is equal to f n plus 3. And if you have to find f of 1, f of 2, f of 3, f of 4. So f of 1 will be equal to, you have to replace this 2fn plus 3 with 2f. N value will be 0 here. Then n value will be 1, n value will be 2, n value will be 3. Now coming to our discrete mathematic recursive definition problems, very simpler problems are there. We'll be quickly going through that. Let us say there is an expression like this. Expression called as an equal to an minus 1 plus an minus 2, an minus 3. And the value of n is greater than equal to 3. And a0 is given to be equal to 1, a1 is given to be equal to 2, a2 is given to be equal to 3. We have to find a6. It means what? The value of n here is 6. The value of n here is 6. It means what? This expression an becomes a6. So this will become a6 is equal to a5 plus a4 plus a3. So a6 will be equal to a5 plus a4 plus a3. a5 can be represented recursively as a4 plus a1, a3 plus a2. a4 can be represented as a3 plus a2 plus a1. And a3 can be represented as a2 plus a1 plus a0. Here you need to remember that the value of n is greater than equal to 3. Now we'll be going on replacing the values. a4 will be replaced with a3 plus a2 plus a1. a3 will be replaced with a2 plus a1 plus a0. a2 will be as it is. Similarly here also a3 will be replaced with a2 plus a1 plus a0. a2 as it is, a1 as it is. So when I simplify this, it will be getting 37. The value will be 37. Let us take one more example. We have expression given as s of n equal to 2s n divided by 2. So here we have to find the value of s of 73. And s of 1 is given to be equal to 1. And n is greater than equal to 2. N is greater than equal to 2. So I'll just do what? S of n will be equal to 2s n by 2. So s of n will be equal to 2s n by 2. And I know the value of n here. What is the value of n here? 73. So 73 by 2 is 36.5, but I am taking the lower integer value as 36. So this again will be represented like this. Go on replacing the s value with the sn value with 2s n by 2. So if you simplify this, ultimately you will be getting the value of to be 64. We'll take one more example and we can stop. As far as recursive definition problems in discrete mathematics are concerned, Fibonacci series. Okay, and the Fibonacci series relationship is like this. F of n is equal to f of n minus 1 plus f of n minus 2. And we know that f of 0 equal to 0, f of 1 equal to 1. Okay, so these are all z plus integers. So now the question given is find f2, f3, f4, f5. So f2 will be equal to f1 plus f0. f3 will be equal to f2 plus f1, which will be equal to f1 plus f0 because f2 will be replaced with f1 plus f0. f3 will be replaced with f2 plus f1. f2 will be replaced with f1 plus f0. And f2 again will be replaced with f1 plus f0. So if I simplify this, I'll get this. Similarly, f5 will be equal to f4 plus f3. So f4 will be equal to f3 plus f2. f3 will be equal to f2 plus f1. f3 will be f2 plus f1. f2 will be f1 plus f0. f2 will be f1 plus f0. f1 as it is. So you go on replacing this, you will get the value of 5. So this is a small video